There are four primary components that make up your cybersecurity policy, and we're going to review those today. The first is hardware. So, hardware that runs within the IT infrastructure is commonly the hardware that we think of when developing a cyber strategy, and that is a majority of the hardware within your environment. But cybersecurity policy also includes hardware like door locks and cameras that are watching over the data center and other components, hardware components, industrial controls like HVAC, for example, or pumping. All of those things have to do with cybersecurity. So, yes, hardware is generally IT infrastructure, but it can extend quite easily out of the standard network, server, storage, and um, compute. So software includes a wide array of components, again, typically found within the IT environment. Those would be things like the operating system, Red Hat, for example, or Microsoft, be databases, SQL, Oracle, and all the others, right? Postgres. And of course, the application stack, anything that has to do with the applications or software that runs within that environment. So, software is everything that occurs. Take that outside of the information technology environment, and you're going to include software, for example, that may run an IoT device or an edge device. You may be talking about software that's used to monitor those cameras or those door locks. So that all, again, is part of the software group when it comes to cybersecurity policy, a gross majority of it still being within the quote unquote IT, information technology realm, but certainly extending beyond that. And as we continue to see the propagation of the Internet of Things and other devices that come into our world, refrigerators and washer and dryers and robots and all of this stuff, all of it's running on some form of software and will continue to impact your cybersecurity policy. Process. Now, this is the process that's used to knit together the hardware and software to actually have it perform a function within your environment. So that process is key. Some processes that you may kind of think about, but not really think about in a cyber perspective is, obvious ones like, what is my access control policy? How do I bring on onboard new users and remove those users when they're no longer working? How do I train my users related to cyber activities, for example? How do I train them not to open up those weird emails with those weird attachments? Things like that. So training is a big thing on policy. What my configuration is and inventory is so that I can quickly and easily fail over to a target site. Again, process. All of this process based. So hardware and software feed right into that process, and then location is very specific as well. Where the physical location is, what the type of building is. For example, is the data center a guns, gates, and guard type of data center, or does it just have a keypad? Is it biometric? What are the physical attributes of the environment? How easily can the power be disrupted? What is the backup power? All of these things, location. So why do all of these elements, these four primary components, why does it matter with our cybersecurity policy? Well, all of it works together, hand in hand, to build a solid strategy for cybersecurity. Without all of this and the consideration and the cohabitation of these primary four areas, developing a cybersecurity policy will be very challenging. So, just one last example. For example, if I'm going to write cybersecurity standards related to my hardware and software, I'm going to want to make sure I select hardware and software that is going to be what I call horizontally scalable, meaning that if I buy for example, a storage that we have here, if I buy storage to support 500 disks, I want to make sure that same storage supports 5,000 disks so that I don't have to go in and rewrite all of my code. If I'm going to start with an operating system that does, for example, a hypervisor, this is certainly no endorsement of anybody's product. But if I did a hypervisor, I would want a hypervisor that I could use today that is fully quote unquote supported and maybe lead me down the road to an open source solution in the future to drive down my cost. So all of those type of things, and Red Hat's a great example of doing that with their implementation of KVM and then OpenStack's version of KVM. All of this has to do with cyber security policy. So establishing the proper policy is very important.